Deep.
Hey Charles, hey
How are
everybody.
you?
Doing well? How are you?
Great, man. We're going deep today.
Yes, we are. We're back to the classic going deep into ServiceFabric with deep.
Right on. So
We have with us AP, as we fondly call him.
Hi.
Recently published author this week, actually. For those that don't know, go to ACM and check out the ServiceFabric paper that he helped write.
absolutely.
So who are you?
My name is Aprameya. I've been in the ServiceFabric team for 6 years now. Microsoft for like 10. So been here for a while. What else?
Why do you work on ServiceFabric?
Oh, yeah, it's kind of interesting. So in India, I was working on a team that was an incubation team for emerging markets, and like we wrote like Bluetooth protocols and stuff like that.
Cool.
And then I think some VP decided that we weren't important, so they killed us. And then we came over to. Then I found a team called Aprameya that was kind of doing distributed computing stuff over here in Redmond. So I moved here, and that team got shut down about 6 months into when I got here. But that team was building on top of ServiceFabric. So I moved into ServiceFabric, then I did some public API stuff, found that I didn't really like that all that much, and then I moved into the Failover area, and I've been there since.
Cool. Fabric is sort of where Matt and Mark also came
Yeah,
from, right?
Matt,
That's cool.
Mark. I think there were a bunch of us who came over
Yeah.
at that point of time.
Cool. So we're going to talk a little bit more about how Failover works today.
Sure.
So you're the first person that we're gonna go. Like we spent some time with Sumuk. So for those of you that haven't seen that video, you should go watch the video we have with Sumuk where he talks a little bit about replication. But today we'd like a little bit of an overview from you on how like Failover works overall, and then let's go deep into reconfiguration.
Yeah.
Since you're an expert with that.
Sure.
Yeah.
So, I think it's important to probably first define what reconfiguration is and what Failover is supposed to do, and then we can talk about how Failover replication work together kind of to make sure, and probably talk a little bit about the federation side, because I think Sumuk's already covered everything on the other side of the replicator, right?
Perfect.
So let's talk about this. So I guess reconfiguration, in order to define reconfiguration, we have to define configuration.
Okay.
In order to define configuration, we have to say a configuration is when is a set of replicas. So a primary and some secondaries together form a configuration. Configuration has something known as, some of these things down.
Sure.
Yeah, so each configuration has something known as an epoch, and an epoch is it's like a set of two numbers. There's a data loss number, and there's a configuration number. And these two together identify a configuration. So, and epochs are increasing. So you start with, whenever there's a change in a replica set, the process of going from one configuration to another configuration is known as a reconfiguration, right? And the implementation of that protocol, how exactly we do the change from one configuration to another configuration, that's the entire reconfiguration protocol, and that's what's implemented in the FM, the RA, and the replicator. So together they kind of orchestrate that. So let's talk about the types of reconfigurations, right?
Sure.
So, or why do we have, or when do reconfigurations happen? So you can have reconfigurations because, for instance, the load balancer wants to swap primaries around. That's a change in the replica set, it's a change in the roles. Or you started a service with saying you wanted 3 replicas, and then you say, I want 5 replicas, and you want to add 2 more replicas. So that's a change in the replica set. Or probably like the most important reason is a primary dies or fails over, right? And you want to actually elect another primary, and you want high availability, which is kind of what ServiceFabric is supposed to do. So that's why you have, so those are some of the reasons for reconfigurations happening. And so now if we then talk about what reconfigurations are supposed to do, or what are the requirements of that protocol, right? So the reconfiguration protocol is what actually guarantees data consistency. And yeah, and it's probably good to think about what are the guarantees that ServiceFabric provides,
Sure.
right? So the first guarantee that ServiceFabric provides is that, well, let's say you are writing a service on top of ServiceFabric, right? And you perform an operation, you perform a write to ServiceFabric, and ServiceFabric acknowledges that that write has been committed to enough number of replicas. And so then ServiceFabric guarantees that every subsequent read is going to observe that write. So if you wrote a banking software and you deposited $10,000, it's guaranteeing that in future, if you come and ask for your balance, there's $10,000, right? It also, but this is not actually possible to guarantee because you have to be storing that information somewhere, and if all of those hard disks get wiped out at the same point of time, well, like how can it magically remember that, right?
Mm-hmm.
So the other requirement or the other thing that works with this is that in case ServiceFabric thinks that or detects that it cannot provide this guarantee, it's going to notify your service. So the only case in which you performed a write, ServiceFabric received it, and you were not able to read it in future, ServiceFabric will have called a callback on your service, would have told you, hey, I detected data loss.
Sure.
Or I potentially detected data loss, right? So these are the guarantees, from consistency perspective that ServiceFabric provides, right? And that's why you write stuff on top of us. So, and you can use these two pieces of state in the epoch to figure that out as well. If you have two configurations, E1 and E2, and they have the same data loss number, it implies there was no data loss between these two. If you have the same configuration number, it implies that the primary between these two has not changed. So it's the exact same primary, right?
So those two are the same, are they considered absolutely identical configurations?
Yes, they're
Okay,
identical.
so switching from E1 to E2 would
So-
not be a reconfiguration.
No, E1 will be equal to
Yeah.
E2 in that case because they're exactly the same, right? Okay, so now if we actually think of this a little more, so let's say that you have a write and you're performing that write W, and this is handled by a primary in epoch EI, right? And let's say you are come and perform a read after you've performed this write, and this is handled by the primary of epoch EJ. And at that point, so if I am to restate what I said, what ServiceFabric is guaranteeing is that R will always observe W unless the data loss version between these two is different, right? So now if you actually think about the relationship between EI and EJ, right? Mm-hmm. There are three possible cases. You can have EI is equal to EJ, you can have EI is less than EJ, and you can have EI is greater than EJ.
And that's in terms of the data?
That's in
data
terms
loss,
of,
or well, when you say less than or greater than, what do you mean?
so epochs are two numbers, right?
Right.
You can compare epochs, and as epochs are increasing, it implies it's like the timeline of the replica
Exactly.
set.
So one is like one happened in the future, perhaps.
Yes. So let's take the simplest case, which is EI is EJ, which implies you performed a write to a primary, and then you went and read data from the same primary, and nothing has changed since then. There has been no reconfiguration.
Okay.
Right. In that case, you really expect that, well, what the reliability subsystem wants of the service author is that you write your code so that you remember what you wrote. So it's like, so we do need the service to participate in.
Keep going. Sorry, I just raised my hand. So the reason I raised my hand is I wanted to call out that we're in the reliability subsystem.
Yep.
Right? That's where we are today.
Yes.
So I wanted to make clear that we normally do for people source, prod, source, reliability. That is the layer in which his work exists. So I just wanted to throw that out there because it's important that people know where it is in the architecture.
Right. Okay. So I think the next interesting case is EI is greater than EJ, right? In that case, what's actually happening is you performed a write to epoch EI, but you performed the read to epoch EJ, and EJ, so you read from an older primary, even though your read happened after the write. And it's a little convoluted to think about, but this can happen, for instance, if the person that's reading or the client that's reading goes to the naming service and gets the address of the current primary and then just waits there. Now there are a bunch of failovers, so the epoch has increased, right? Now somebody else comes and performs a write. Now this previous client comes and performs a read. So he's performing the read to an older primary, even though the read is happening after the write. And you have to, so in this case, and this case is also interesting, so in this case there are two things that need to happen, right? You have to make sure that in order to preserve those guarantees, you need to have a mechanism so that the service can detect this condition and tell the client, hey, you're not talking to the right primary, go back to the naming service, there is some other more advanced primary and that guy has actually got the data.
So does that mean at this point that primary might be a secondary, or does that just mean it's an outdated primary?
It could be a secondary, there could be a network partition, or you could just have had like just timing, right? You came and exactly at that moment we failed over.
Yeah.
So in distributed systems, these kinds of things just, they can happen, right? So
For sure.
the mechanism in which, in ServiceFabric, which allows you to do that is something known as the read status. So when you're writing a service, you have access to something called the read status, and this is something you're supposed to check as a service author before you service a read. And if you're using the reliable collections and so on, they'll kind of do this for you. And so it again depends on what level of ServiceFabric you're programming at. So if you check the read status, that primary is going to, the read status at that point is going to say not primary, meaning I'm not the primary, you cannot service this read. And the expectation is that the client will observe this and then see, oh, I'm not primary. I need to find who the current primary is, go to the naming service and say, okay, give me the address of the latest primary. That should eventually return the address of EI or whoever is the current and go and read from there where you will observe W. So that's the mechanism in which that's supposed to work. And so for this, again, you need two things to happen. You need the service. So the service must check the read status. So if your service is written in a way that it's not really looking at the read status before it replies to clients, it's just blindly reading the data and returning it, we cannot guarantee consistency, right? As we have defined it. And the second thing is Windows Fabric must make sure that the read status is being revoked before we elect a new primary. Because if we don't do that, or if we have a bug or something, that means you can go to an older primary and still read data. And that's not consistent anymore.
Great.
Right? So these are the two, these are two of the three cases. So let's talk about this, which is actually the most interesting case. So this is EI is less than EJ, and this is the most common case. You performed a write, and then there were failovers, swaps, a whole bunch of reconfigurations happened, the replica set kept changing, and maybe one day, 1 year, 10 years in the future, you came and asked to read, right? And at that point also, the guarantee must hold, means you must observe W. And if you don't observe W, then Windows Fabric must have told you there is data loss, right? So I think the simplest way of implementing this is every time there's so if there's no failover, you don't have a problem. If there is a failover, Windows Fabric can just say there's data loss. That's like the naive implementation of this, which is not a very useful implementation because it's no longer telling you, like, it's not usable at all.
Yeah.
Right?
Just saying that, by the way, we failed over, so we lost something.
Yeah.
Now you know we lost it, but you don't know when or why. Or,
yeah. You don't know anything, right? So then, what Windows Fabric does is it says, okay, so let's say your replica set size is n, which means you have n replicas defined,
Okay.
right? In your configuration. Windows Fabric says that, let's say there's define a number called read quorum, which is 1 less than equal to, which must lie between 1 and n, right? So Windows Fabric says that between EI and EJ, no matter how many reconfigurations happen, as long as a read quorum of replicas was available and had their state, it will provide this guarantee, right? So it does not require, it's not as unusable as by we're just going to declare data loss. So we'll declare data loss only if a read quorum has lost its state.
And how is a read quorum defined?
So read quorum is a number between 1 and n.
But how do we pick what it is? It's just, why is it not just 1 every time, for example?
Let's come to that in
Okay.
a little bit. Yeah. So
Other thing I want to point out now that I've broken your chain of thought is you've been on the team so long. It's awesome that you still call it Windows Fabric.
oh
Yeah, that's okay though.
Yeah, it's cool. It's like you guys are speaking to original people that wrote this stuff
Yeah.
and talked about this stuff.
Absolutely.
So it's awesome.
Great. So RQ is a number between 1 and n.
yes.
That's what we know so far.
Yes. And yeah, okay. So then let's, so with that we can say, okay, as long as you have a read quorum available, Windows Fabric won't declare data loss, right? So now let's define a couple of other requirements that we have on top of just this. So because we still need the replicator and the service to participate in order to still, so that the reconfiguration protocol can guarantee this, right? So let's define another number called the write quorum, right? So the write quorum is defined as n minus read quorum plus 1. So it's basically saying that you have two numbers, or you have actually one number, the read quorum or the write quorum, whichever one you want to pick, right? You pick that between 1 and n. The other number can be derived like this, and it's saying that there is an overlap of one replica between the read quorum and the write quorum, right? And so with that you can say, and then let's add some more requirements on top of the replicator, right? So, and the service. So we say that a service cannot say that cannot acknowledge a write until and unless it has been persisted and applied on a write quorum number of replicas. So if W came into the service, it cannot say that W is complete, and Windows Fabric will not, or the replicator cannot say that W is complete until unless it has been replicated and applied to a write quorum of replicas. Right? So we require that of the replicator.
Yep.
So that's what failover requires from the replicator. It also requires a couple of other things. It requires that if the replicator tells a state provider, if the replicator says, okay, here is some state that has been replicated and you need to make it persistent, you need to apply it, right? You cannot say, I'm done, and then in future say, I don't have that state. Or if you are in that kind of a situation, you have to tell Windows Fabric, you have to report fault permanent saying that I've actually lost my persistent state, right? And that's kind of easy to see why, right? If you are just a replicator or a state provider that never writes anything to disk and your process crashes, there's nothing much we can do.
Sure.
Right? So with those two, right, with that we can actually then go and see what the protocol and how it kind of works on figuring out who the new primary should be and what are the steps that new primary needs to take in order to complete a reconfiguration and move from one epoch to another epoch, right?
Mm-hmm.
So obviously, let's say the old primary crashes, right? The first step you have to do, and you have n replicas. The first step you have to do is figure out who should be the newest replica, right?
Leader election.
Yeah, leader election. You have to figure out who should be the new primary. So, and that phase, so the reconfiguration protocol has few phases, right? So that phase is called phase 1, and that is get LSN. And at that point, Windows Fabric goes to bunch of these, to all of the replicas that are there and says, give me a sequence number or give me the LSN of your highest state or your LSN. What's the sequence number corresponding to the latest replication operation you have persisted on your disk, right? Then goes to these guys and it picks the replica with the highest sequence number and makes that the new primary, right? So there are a couple of things here. So the first thing is how many replicas it needs to ask, right? To make sure that it doesn't lose any state. And it actually needs to ask exactly a read quorum number of replicas. Because a write quorum number of replicas must have acknowledged all of the operations, right? For those operations to have been considered committed, right? Between the read quorum and the write quorum, there's always one overlap. So you need to ask a read quorum number of replicas, and you will find at least one guy who has all of the state. And that's how you figure out, okay, we pick that guy as the primary, right? And that's why this one is important. And one is sufficient because it doesn't matter if you have 1, 2, 3, or 4. If the overlap is bigger, right? You just need to find the minimum number so that you can be done as quickly as possible.
What happens in the case that there's multiple nodes that have the same LSN? How do you pick leader across?
So the way it works, and that's a good question, right? The way it works is whenever the failure is detected, the failover manager asks the load balancer who it thinks should be the best, who is the best primary candidate,
yeah.
right? According to the load. So that if we make this guy the primary, the cluster would still be the best balanced, right? And that's really, it's not the complete load balancing logic running at that point. It's like very, very optimized because you don't want to be slow in this code path because at this point you don't have a primary, right? You want to pick a primary as quickly as possible, right? Now, it's possible that the load balancer picks somebody who is behind or who is slow or incorrect to be the primary. At that point, the protocol can actually override that and pick the correct replica to be the primary. It will override the load balancer's decision. The reconfiguration will actually complete with that guy as the primary. Then the load balancer will notice that the cluster is unbalanced and actually go and rebalance it again, right?
So there's still a chance though that you have two secondaries that have the highest level of LSN. Load balancer comes in, picks a third one. Now you have to override the load balancer, but you still have two to choose between.
Yeah.
Then how do you pick?
It's random.
Okay, because at that point it shouldn't matter because you're not
matter.
picking the most optimized via the load balancer, but you are picking the latest state.
Yes.
And the assumption is in the next cycle of load balancing, which happens seconds later, effectively, you will reach a point at which you'd have the most. The primary would then become the most optimized place for the primary to be. Okay.
Yep.
Cool.
So with that, you can be sure that you will have picked the right primary, right? So you don't end up picking some guy who doesn't have a quorum committed LSN and causing data loss, right? At that point, you basically lost that data if you pick him, right? So that's the first phase of the reconfiguration protocol. Then you need another phase, which is you need to make sure that this new primary and this new configuration, all of the write quorum of replicas have all of the state that was there in a read quorum of the previous configuration. You want to make sure that all future primaries will have all state that was there in all past primaries, in all past configurations. Otherwise, what could happen is you end up in a situation where you've actually missed out on some reads.
Well, interestingly, going back to your previous example, it would mean that you won't be able to observe W effectively when you do the read.
Yes.
Yeah.
And actually, I think we can talk about this with an example, right? So let's say you have 4 replicas, A, B, C, and D, right? And let's say that and this is in epoch E0, and this is the replica, and this is the LSN, right? So you have 3, LSN 3, this guy has LSN 2, and this guy has LSN 3, right? So at this point of time, since there are 4 replicas in E0, the write quorum, based on our current algorithm, is 3, because that's what a majority have, and the read quorum is 2. Right? So now let's assume that there is a failure. Actually, there are 2 concurrent failures, right? A and B both lose their state. So their hard disks get completely wiped out at the same point of time.
What do you mean by DD?
DD is dropped, meaning they've lost their state.
Disk drop, data drop.
Data drop, yeah. That's what.
Whatever you want.
What I want to call it? Okay, cool.
So at that point, we're going to have a reconfiguration and we're going to move to a new configuration that has, let's say, just C and D, right?
That's problematic for other reasons though, but yeah.
So let's say we have just C and D, and at that point, and the get LSN phase is going to ensure that D is picked as the new primary, right? So, and let's say there is none of this. So the phase I'm actually talking about is phase 2 catch-up, and let's say there is no catch-up phase, and we perform it should be 3. So we perform the reconfiguration, we do the get LSN phase, we find the most advanced guy, and we say, okay, you're the primary, well and good, everything's happy, and client comes in or performs a read, he will observe 3, which was the quorum committed LSN, right? Now let's say from here, C gets dropped, or let's say D gets dropped, which will fall. D gets dropped. Now we're going to have another reconfiguration, and in that reconfiguration, the get LSN phase is going to run for if n is 2 and your write quorum for n is 2, which is a majority, then you need one replica to respond to get LSN. And since C is there, C is sufficient. So this reconfiguration will complete with C having LSN 2. And we'll say no data loss has yet been detected because we've always had read quorum of replicas available, right? So now if a client comes in and wants to read, he cannot find 3. And we've actually violated those 2 guarantees we had because we never declared data loss, right? So that's why, so what actually happens with phase 2 catch-up is for this reconfiguration to complete, D must ensure that a write quorum over here has all of the state, which implies this is not possible. What will actually end up happening is that E1 will not complete until C has 3. And now if D gets dropped, E2 will have C with 3. And that's why it will, so that's why it works.
But even this can actually happen, right? Because suppose during catch-up, this node goes down, the node carrying D. So this is still a viable thing that would happen. Yeah.
So now let's say that we are in catch-up, right? And we haven't completed catch-up yet, and at that point, D gets dropped. At that point, E1 never actually completed. So the reconfiguration that's going to actually happen will happen from E0 to E2. And at that point, A is dropped, B is dropped, and D is dropped. And so we're going to see that out of a replica set size of 4 in E0, you don't have a read quorum, 2 replicas up. So now Windows Fabric is going to declare data loss. And it's going to bring up E2 with C and 2, and it has declared data loss, so it's following those definitions that we have. And that's why we have these 2 phases, get LSN and catch up in the reconfiguration protocol that work together. So that's, I think, like a high level and the overview of what the different phases are and what the requirements from failover, the FM, the RA, and the replicator and the service are to all work together to make sure that we can give those consistency guarantees saying, okay, why, like saying that, or rather, these are the algorithms that run when there's a failover to make sure that your state is still preserved, right?
So in the case of this data loss, though, let's just say I'm a user that has critical data being stored in my stateful service. I have this situation happen to me, so I jump from E0 to E2. I know that there's data loss. What do I do?
So you go and most probably you've been taking backups and you restore from those backups.
So ideally at E0 at some point I'd taken a backup. Yeah. And this goes into more conversations on disaster recovery and what your recovery point objective would be really. Because you want to make sure that at all times you're taking backups so that if this ever happens to you, you can either make the conscious decision of saying I can drop from 3 to 2 and be okay with it, or 2, I should have taken backups so frequently that I would have known about 3 and been able to put 3 back.
Yep. Okay. Exactly. And this is usually, it's rare because for so many machines to lose their hard disks at the same point of time, it's unlikely, and you would probably go and if you think that can happen, you probably want to have more replicas to begin with. So you say I have 5, which means, or I have 7, which means I can actually survive 3 concurrent failures.
So I have a question. So when we create ServiceFabric clusters and everything that goes around it inside of a data center, do we really like position ourselves in this co-located physical space? So in other words, wouldn't it be safer? Because the speed it takes the network on one corner of a data center to another is nothing. So this is my question. So if I guarantee that my disks are not located in the same place, co-located in the same physical space, that's probably good.
Yeah.
So we should have algorithms that ensure don't put us all on the same physical space, because perhaps there could be some cascading effect with like electricity or whatever.
Right.
So is that what we do?
Yes, actually. So we have the concept of fault domains, right? And fault domains are hierarchical. So so they can be like at the level of different racks. And so by default, the load balancer is not going to place two replicas in the same fault domain. It's going to try to optimize across that, right? And so there's another interesting thing here, right? There's a difference between dropped and down, right? So you can have two situations. One where a replica loses its state, another where a machine or a replica goes down temporarily, but it's not lost what it has on disk, right? So if you've lost your state, that's data loss, right? If you just go down, we're going to elect a new primary. If enough replicas go down, you're actually in quorum loss. And at that point, you're stuck, right? So let's say that instead of getting dropped, these just went down. Let's say you had the misfortune of having 3 machines go down at the same time, or the misfortune of having a data center go down at the same time, right? At that point, all of these reconfigurations are just stuck. They're not progressing. You'd be in this like transient kind of state, right? And you query the system, it would say reconfiguring, there'd be health events saying partition is in quorum loss and so on, right?
One of our favorite health reports.
Yeah, okay, sure. And so we're basically stuck. We're waiting for enough replicas to come back up and report their progress so that we can actually elect a new primary and proceed with this protocol. So the reconfigurations actually, the protocol will get stuck in order to guarantee correctness, right? So we will, and there is a setting which allows you to actually proceed after a amount of time, like it's configurable, how long to wait, and by default that configuration is infinity, because we don't want to declare data loss unless someone tells us authoritatively that the replicas have actually lost their state. So if this ever happens and you're in quorum loss and you know your machines are like dead or your hard disks are gone, then you can come to ServiceFabric. There's an API which tells us, okay, now proceed. But it's an administrative action. You have to take it yourself. ServiceFabric will not automatically do that.
So we assume that machines are down when this happens.
Yes.
So in this case, suppose they were actually down and you didn't have true data loss, and this came up, we would actually never even reach E2, because you would be stuck here until me as a user came and said, I've actually lost my data. Because the better case scenario, the more realistic case is I was able to go and reboot the machine, or the machine came back up, and one of these guys came back up with state 3. In which case I'm not really going to this E2, I'm probably going to E1. Assuming one of those machines came back.
You're going to go and make that replica the primary.
Right.
Yeah.
Which had the latest data.
Yes, which had the latest data.
Cool.
Right. So that's why reconfigurations get stuck. So now I think we should talk about that choice of, so the code itself or the algorithm itself does not require a specific value for these numbers. It will work regardless of what value you choose, right? And there can be like several different choices that we can make. So let's say I choose a write quorum of n. This implies that every single replica must persist the state before Windows Fabric tells the user that, it's good, right? So this implies that you need more replicas to commit. However, during the get LSN phase, you can pick anybody as the primary, right? So pros and cons. If you choose write quorum as 1, that implies just the primary committing is sufficient. However, if the primary goes down, it must come back up. Otherwise, you will lose the data, right? So
there's a chance you'd lose the data. It depends on whether or not there was a write happening when it went down.
Yeah, there's a chance that you would lose the data. And so I think what Windows Fabric does is it requires a majority of the number of replicas in the replica set to go and choose. And so this logic is hard-coded, but it's changeable. We have like a design and partial implementation to actually change it, kind of like have a slider where you can say, okay, I want 1, 2, 3, n replicas to, actually.
So that's to give people the flexibility when they know they're fine with
Yeah.
certain ways,
Yeah.
or they really absolutely need maximum reliability.
Yeah. So that's for that purpose, right? Yeah, so, but the algorithm and the logic itself does not require any of this, right? Yeah, so that's the protocol itself, and that's how we actually guarantee consistency. And this protocol is implemented by, like parts of this protocol are implemented by different components. So there's parts of it in the FM, there are parts of it in the RA, and then there's parts of it in the replicator, and everybody is working together to provide those consistency guarantees from Windows Fabric's perspective.
And they're all in the same subsystem.
Yes, there's
Because
all
you wouldn't want to have a dependency on a different subsystem.
Yeah, this is all
by
part
design.
of reliability. Yes.
Yes. It's important.
Yeah, it is. So let's talk a little bit also about reconfiguration specifically, not from a service fabric deciding that this is a good thing for you, but maybe from I am a user of service fabric and for some reason, and you can tell us more about why this might happen, I want my secondary on a particular machine to become a primary, and I just want to override any logic that's available inside service fabric to do that.
Yeah.
One, that is an option. Why is it an option? And two, in what cases would you advise that somebody should actually think about doing that?
So I think it's important to understand how that is actually defined as an option, right? So I think we have a command which says move service fabric primary or
Yeah.
something like that, which
Yeah,
says,
that's
okay,
it.
this is a primary, this is a secondary, move them. Like I want this guy to be the primary, right?
Yeah.
And how do we do that without violating consistency? And that's actually, so the reconfiguration we talked about is a failover, in which case the old primary has gone down,
Yep.
right? We don't know. This reconfiguration is a whole different type of reconfiguration. It's actually called a swap primary internally. And this is being initiated as a result of a user action or the load balancer. It's actually, swap primaries are only ever initiated by the load balancer. And when you say move service fabric replica, you're actually telling the load balancer, hey, like this is what I want, right?
So this could actually happen because of something to do with machine statistics as well and performance.
Yes, or upgrades or
Whatever.
like load in the
Yeah.
cluster, right? It's the same reconfiguration that happens. So as opposed to all of those phases that are running, right? There is one additional phase that runs, which is called phase 0 demote as part before get LSN and so on. Actually, get LSN are not strictly required, but we do run phase 0 demote. And at this point, the reconfiguration is being orchestrated by the old primary. And that's going to actually ensure that the primary, the replica you pick, the secondary you pick, has all of the state that this guy has before demoting himself to a secondary and before this guy is promoted to primary. So even though you're saying move service fabric replica, it's not the same as a failover. It's actually orchestrated by us with the old primary saying, first making sure that all of the state goes there. So if you were to go back to that example, you have 3, 3, 2, and 3, and you say move primary from A to, and let's say this guy was the primary, and this guy is the secondary, everyone is the secondary. Say move primary from A to C. The first thing that's going to happen as part of this reconfiguration, and let's say in the new epoch, I mean you want to go to this new world where A is a secondary, B is still secondary, C is the new primary, D is the new D is still a secondary. The first thing that's going to happen is A is going to make sure C has 3. Only after that happens will A actually demote will A actually go from primary to secondary, and only after that happens will C go from secondary to primary. And so the actual state that's going to be there after this is this. So, and you will observe that.
So how do you handle incoming writes at the same time here? So who, like, because A is still the primary, I'd suppose I manually or the load balancer decided that C now needs to become the primary. At the same time, I have a user coming to my website, and because of whatever they're doing, there's a transaction happening, there's a write happening. How do you process that? Do these things happen in order, or do we prioritize the write? What do we do?
There is okay, yeah, I see what you're asking, right? So on the timeline, there's a point at which so this is A. So there's a point at which on A we are going to say you are no longer the primary and you are being demoted from primary to secondary. And that's kind of like the hard barrier. There is a barrier, and so if you still have stuff in flight, that's all going to be rejected. And if you had a client request come in, it would observe not primary, and you'd have to go to the naming service and get the address of the new primary, and which will most probably, by then the reconfiguration will complete and be C, and you'll go to C and make your write.
Is there ever a case in which we could say there is no primary? Because you made that request at a time where everything is a secondary.
Yeah.
Because A has been demoted and C has not yet been promoted.
Yeah. Or you're making requests when you're partitioning quorum loss, for instance.
Sure. And then in that case, we don't accept writes.
We don't accept
So you
writes.
have to have retry logic in your application.
Yes.
Basically. Okay. So you have to build that in, right? So as a user, when you're thinking about running stateful services, you have to make sure that you have some kind of retry, and
Right.
so that when these things happen, you're not left being like, wait a second, I can't make any writes to my stateful service. I want to ensure that I have no data loss, but for some arbitrary reason, I can't make any writes at this time.
Yeah.
It's interesting.
Yeah.
Sure.
And the aim of that entire protocol is to be as quick as possible between this point to this point,
Yeah.
so that the period is minimized, but that period can never be made zero. So you always have to program for this happening.
Do we know how long that period is for
Depends.
reconfiguration?
I think for our P clusters, which are the clusters that actually run all of the Azure services and SFRP and so on, I think it's under a second for most reconfigurations.
Okay.
Yeah.
And how did we get it down that fast? Just optimizations in the algorithm, or is there hardware-related decisions as well?
Yeah, I think there's hardware plays a big part. If you have like a really slow disk, there's nothing much you can do, because all of this data, metadata about all of this needs to be written by ServiceFabric, right? And we do have lots of optimizations in the algorithm itself. For instance, we don't wait for every single replica. We wait for like the bare minimum number of people required to tell us stuff so that we proceed. And there's also like a lot of code related optimizations to make sure we are, as fast as possible getting this done.
So suppose I'm a company that needs an extremely low latency operation at all times, whether that's especially when I'm accepting incoming writes and then handling multiple reconfigurations because I have volatile infrastructure or whatever. In that case, you just said that hardware makes a pretty substantive difference, which means I need my disk I/O should be relatively quick.
Yeah, I'd say SSDs.
Yeah. So, but it's interesting because it's not just the machines on which the ServiceFabric system services are running. It's actually every single one of your nodes has to be able to do really fast read, right? Because it's at the log level at this point that we're ensuring that secondaries catch up.
Yep.
Yeah.
Yep.
So it's not just enough for you to say, I have a node type that contains my ServiceFabric system services, which is a pretty typical pattern we see, which is you have one node type which has your system services, and then you have a second node type which actually has your application deployed. And that scales up and down because then you're able to scale safely without affecting your system services, basically. So you can have reliability in the cluster being up, even if you're coming down all the way down to one node on your secondary node type. But in this case, what we also see people doing is figuring out what is the optimal way in which you don't have to pay the most.
Yeah.
So you see, do I skip more on the node type? But it's interesting, right? Like,
This makes sense.
Yeah, do I get the node type from my system services that is not the highest and not the fastest, or do I get not the highest and not the fastest from a workload? And it seems like it's actually, you should get the more optimal node type for your workload if you care about this.
Yeah, I think that before, like, the hard disk speed for the ServiceFabric portion of these writes would come into the picture, you'd be observing it in your application itself. So your application will be slower, like by definition, and that's what's going to be happening most of the time.
Right.
And the amount of data we are writing, like each of these times we do writes, and we probably do very few, like 4 or 5 writes in an entire reconfiguration, right? Yeah, probably, yeah. So would be less than kilobytes, right? Would be less than a kilobyte, right, each time. So it needs to be low latency more than, and fast in terms of throughput. But again, I think you will notice it more in your application way before you will start noticing these things, at the ServiceFabric
Fair enough.
layer. Yeah.
So what are some of the challenges you're facing today now with the RA specifically?
I think, so a lot of the challenges were with respect to like when we had the original reconfiguration protocol, certain phases would require all replicas to participate and so on. We made changes to that because what we see happen is, given a set of machines, usually there will be one machine that's causing a problem. And that one machine originally, previously, could like slow down reconfigurations or commits and so on. We've been tuning this protocol in such a way that we no longer have no phase requires every machine to participate. You can proceed on, majority or read quorum or a write quorum, and you don't define n, which is one of the reasons why you should preferably not choose n, because at some point, some machine is going to have a problem, and you don't want to wait for that machine to do something, right? So I think the key changes have been in terms of, making that better. And I think the other main challenge was we had in terms of health and diagnostics and, making sure that some of this stuff is easy to understand. So we had just one health report, partitions and quorum losses. I think the other one is reconfiguration is slow.
It's slow, yeah. Those are the two.
You would have like, okay,
what
what's
does
the
this mean?
reconfiguration? Why is it slow?
So what should people do when they see that now?
So I think one of the key things is we've been enhancing this a lot. So if you look in SFX, if you're just on the partition page, it will just say reconfiguration is slow. Then drill down further into the health report on the primary, and you'd actually get a reason of which phase of the reconfiguration is stuck. We'll tell you like which replica is kind of, we suspect, slow or stuck. And another thing is it's good to look at all of the health events, because sometimes SFX may not render every single one. It might just render one, or it might scroll down all the way to the bottom. You definitely see health reports from, the RA, which will say, okay, like, so the FM will report that the reconfiguration is stuck. That's what you would see on the partition page. Then you go to the primary and you see a more detailed health report saying which phase of the reconfiguration is stuck. And then I think you'd have another health report, for instance, you're writing a service, a reliable service, and you have a bug in your code where you don't honor the cancellation token, right? You'll probably have another health report which will say that, oh, the reconfiguration is stuck in phase 2 catch-up, right, or phase 0 demote. And then there'll be another health report which will say that the cancellation token is not being honored, and run async cancellation is taking too long. So it's important to look at all of the health reports to get a clear picture, because every component has a limited view. So it can only report based on its view. And as you go lower down that hierarchy, you can get a better idea.
And is that something that you expect people to be able to fix on their own once they've diagnosed it correctly, or is it more of a, at least I've localized the problem, now let me come to ServiceFabric and be like, guys, help?
Yeah, I think like at this point, so it depends on the class of the problem. If the problem is a user bug, if the bug in your application, you should never have to come to ServiceFabric to ask us, hey, like my reconfiguration is stuck. And then it should never be the case you come to us and we tell you it's a bug in your code. You should be able to discover that yourself, right? Everybody has bugs. And other reasons why reconfigurations can get stuck is because because of hardware issues, right? Just the machines are down, right? And that's nothing much we can do about that unless and until you're on SFRP, in which case you can yell at us, right? But in those cases, you go and look at the machines and like bring them up, for instance, right? The health should tell you that.
Or let us know that there's data loss so we can...
So I have a question, without getting into details, because we haven't really talked about them yet. But in a world of serverless, even though there's actually servers there, and mesh, and you're sharing machines, virtual machines on physical machines, and you're not going to be able to access this level of the system by design.
Yeah.
Like you shouldn't ever have to worry about this in the mesh world. What is that doing to you in terms of modifying, adjusting, creating new algorithms to support that type of workload?
Right. So I think at this point we still have, optimizations in terms of algorithms we want to do, and it's not just reconfiguration that the reliability subsystem does. So there are other things. For instance, you have a stateful service, which is your mesh thing, and you start off with one partition, and now you say, well, that's too few. I need more, and I want 3 partitions. Well, you already have some state in that service. We have to actually move that state around reliably, right? With minimum downtime for availability, and making sure we don't lose any of it in the middle, right? So we have to support scale in and scale out of stateful services. So those are some of the, new interesting challenges. And of course, we want to make sure, since you have no idea about any of this stuff, we want to make sure that we don't spend a lot of our time just debugging and investigating this. So our own health report has to be, the more it's automated, the more it's simpler to fix.
Cool.
Cool. One last question for you.
Yeah,
Completely random. What is your one piece of advice for anybody watching this video related to anything in the world? Whatever you'd like to say. Doesn't have to be related to this.
Do quality work. Yeah, I mean, invest time in read and understand stuff.
Cool. Thanks so much, AB.
Yeah.
Appreciate your time.
Thank you.
Great answer. Hey, this was a great conversation.
Yeah.
Nice job. Great to finally meet AP.
Yeah,
And
great
we're going
guy.
to continue this.
Yeah,
next
we're going to
time.
have a second one. We'll meet with Mansoor probably and talk a little bit more in depth with the FM.
Source, prod, source, reliability.
Yeah.
And then just look for AP. Just kidding.
Look for the RA.
Look
Yeah,
for the
yeah,
RA
yeah,
folder.
yeah.
Check
Yeah.
out those algorithms, folks.
Yeah.
It's right there for you to see.
Yep. Thank you.
Peace.
Yeah, thank you.